So we're going to learn how to use the quadratic formula to solve kinematics problems. So here's a problem that we've seen before. An object is dropped from the roof of a building, and we want to know how long is it going to take to hit the ground. Only every time we've done a problem like this, the object's been dropped from rest. In this case, it's going to be given some initial velocity. In this case, it's going to start off going 10 meters per second, downward. How do I know it's downward? Because I look at this arrow here. So I know the initial velocity is downward. I'm going to make sure to make a note of that when I'm listing my variables so I can be careful to give all objects pointing in the same direction, all vectors pointing in the same direction, the same algebraic sign. What else do I know in this? Well, it's a free fall problem. So I always know acceleration in a free fall problem is acceleration due to gravity, and it always points downward, and that is 9.8 meters per second every second. I also know 50 meters. That would be my displacement. Because this is a vertical displacement, I'm going to list it as delta y to indicate that it's vertical. It's 50 meters. And to find the direction, I need to ask myself, well, from start to finish, did this thing move up or down? Was its displacement up or down? It started here, it finished here, its displacement was down. My unknown is how long will it take? How long will it take is asking me to find time. So time is what I don't know. So let's take a look at the variables. I'm looking, all my arrows are pointing down. So every one of these quantities rather that is pointing downward has to have the same sign. It can be positive or negative. It doesn't matter. I'm going to leave them all positive so that the way I'm setting up this problem, I'm calling downward positive. Everything that points down, I'm going to call positive, and everything that points up, which is nothing, I will call negative. It just makes my calculations easier. Could I make this negative? Sure. But if I make acceleration due to gravity negative, that's pointing down. I have to make every other vector that points down negative too. I'd have to make all of these negative, which you could do. You would get the same answer. You'd still get the right answer. It would all be fine. But I'm not going to do that. So I need an equation with initial velocity, acceleration, displacement, and time in it. And the equation that we have with those four variables is this one. Delta y, or delta x, is v naught t plus 1/2 at squared, or I'm going to write 1/2 gt squared. It's a free fall problem. So acceleration is acceleration due to gravity, which is 9.8. So every single time we've done a problem like this, when we've used this equation to find time, initial velocity has been 0, so we've been able to get rid of that term. But in this case, initial velocity is 10. We can see here that initial velocity is 10. It's not 0, so I cannot get rid of this term. 10 times some number is not 0. I have to keep this term. So what do I do? Well, I notice here I have a t squared and I have a t, and this is actually a quadratic. Ax squared plus bx plus c equals 0. When I get an equation in this form, I know how to solve for x. X is negative b plus or minus the square root of b squared minus 4ac over 2a. So the first thing I'm going to do here is I'm going to rewrite this. I'm just going to rearrange the terms a little bit so they're in this x squared x and then just that number without a variable, set this whole thing equal to 0 and put it in this form. So I'm going to start with my squared term, 1/2 gt squared plus v naught t. All I did here was switch these two. And I can do that, right? This is like 5 plus 2 and 2 plus 5. It's the same thing. I can switch the order of those. Now I want to set this equal to 0, so this is over on the other side of the equal sign. I'm going to subtract it, minus delta y. Whatever I do to one side, I have to do to the other. Minus delta y, it equals 0. Now this is in this form. This 1/2 g term is the a, this v naught is b, and negative delta y is c. I have to keep track of that negative sign there. Now what I'm going to do is put the numbers in, and I could isolate it. I could isolate t, I could put it into this equation, so I could say time is negative b, that would be negative v naught plus or minus the square root of v naught squared minus 4 times 1/2 g times negative delta y over 2 times 1/2 g. I could plug this all in with my variables in it. And I know I make you do things like that usually. But in this case, it gets very cumbersome. It's a lot of numbers to carry around. It's a lot of chances to make a mistake, a careless error. So here I'm going to put in the numbers first. So for this 1/2 g, I'm going to put in 1/2 g. Well, g is 9.8. So 1/2 g is 1/2 of 9.8, which is equal to 4.9. So I'm going to write this as 4.9 t squared. I'm just substituting my numbers in early. V naught I'm given is 10 t, and then it's minus delta y. Well, delta y is positive 50, so I'm going to write minus 50, and that equals 0. So now that I have it in this format, all I have to do is substitute these numbers into the right spot in this quadratic formula. So just to make sure I get this right, this 4.9 is going to be the A, 10 is B, and C is negative 50. I've got to keep track of that negative sign. This is where it helps to write neatly. You don't have to jam this into the smallest amount of space you can on your paper. Leave yourself some room to write it out so I can see what you're doing, and especially so you can see what you're doing. So this isn't x's here. It's not x squared bx, it's t squared. So I'm not solving for an x here, I'm solving for a t. So t equals negative b is going to be negative 10. And you don't have to put units in on this either. I'm not going to mark off for not putting units. Plus or minus the square root of b squared, right? B is 10, so that's 10 squared, minus 4. The a term is 4.9. C is negative 50. This all goes under a radical. And it's all divided by 2a, which is 2 times 4.9. When you do this, you're going to get two roots. You're going to get one when you add, and you're going to get one when you subtract. So when you put that into your calculator, for the positive, when you add them, you should get 2.3 seconds. When you subtract, you're going to get negative 4.4 seconds. So what does this mean? In this case, this is pretty easy. Negative 4.4 seconds has no meaning. It has no physical meaning. Time can't be negative. So I know that one's not right. I know that the time that it takes to reach the ground is 2.3 seconds. Put this in your calculator and make sure you can actually get that answer. Not just that you understand how to set it up, but that you can get the answer. So here's another problem. Everything's the same as in the last problem, except now you're throwing it upward instead of throwing it downward. So your initial velocity is 10 meters per second up instead of 10 meters per second down. We still have acceleration as acceleration due to gravity. It is still downward. It is always downward. And the displacement is still going to be, oh, look, I already put a negative sign there. The displacement is still going to be downward, right? It's going to start up here at the top of the building, and it's going to end up down here at the bottom. It is going to travel 50 meters down. So since I have one vector pointing up, I have two vectors pointing down, I indicate that they're in opposite directions by giving them opposite signs. I can make up negative and down positive, or I can make up positive and down negative. It does not matter. All that matters is that if I decide downward is negative, that I put a negative sign in front of every negative vector, everything that's pointing downward. So I'm going to decide that downward is negative and upward's positive. So every vector that points down, I'm going to put a negative sign in front of. So acceleration's pointing down. I'm going to make this negative 9.8. Delta y is downward, so I'm going to make that negative 50. And I have to keep track of these. So again, write your stuff out neatly enough so that you can go back and see where you put the negative signs. This is, in order to find time, I need to find an equation with initial velocity, acceleration, displacement, and time, and it is that same equation we've been using. So delta y equals v naught t plus 1/2 gt squared. When you solve this, you should get, when you add it, you should get negative 2.3 seconds, and when you subtract, you should get positive 4.4 seconds. So make sure you can plug these numbers in and do that. And if you can't, just hit play again, and I'm going to go through how to solve it. So this is a quadratic. Ax squared plus bx plus c is 0, and the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So my first step is going to be to put this into this form with the t squared term first. So 1/2 gt squared plus v naught t minus delta y equals 0. If you did not get the right answers, it was probably in substituting that you made this mistake. Watch your signs. 1/2 g now is going to be 1/2 of negative 9.8, so that's negative 4.9 t squared plus v naught is still 10 minus negative 50. So this is where you could screw up also. So you're supposed to subtract delta y. Delta y is negative 50. When I subtract a negative, it's a positive, so I'm going to get a positive 50 here. And that equals 0. Now I'm going to just plug it in to the quadratic equation. T equals negative 10 plus or minus the square root of b squared, which is this 10, minus 4 times minus 4.9, right? This a term is negative 4.9 times c, which is 50. Put all of that under a radical, all over 2 times negative 4.9. Now, if this is how you set it up, and you did not get these answers up here, then you are messing up entering it into your calculator. Try to figure it out. We'll do one more problem. So here's another problem where we would have to use the quadratic equation combined with kinematics to find out how long this event would last. So the problem says a rocket is launched upward with an initial velocity of 1,000 meters per second. How long will it take for the rocket to reach a height of 30,000 meters? So it's always helpful to draw a little sketch so you can figure out what you're dealing with here. We'll make this the rocket. It starts somewhere, and it ends up going 30,000 meters in the air. We only care about really this rocket going up 30,000 meters. So our delta y, or delta x if you prefer, is going to be this distance here. It's going to be 30,000 meters. And we know we're told the initial velocity is upward, and that is 1,000 meters per second. And so this is the information we have. I'm going to list the information here, the variables we know and the variable we're trying to find. So I know the initial velocity is 1,000 meters per second, and I'm going to put the arrow over here so that I can keep my sign straight on what's positive and what's negative. I know that the displacement is going to be 30,000 meters. And is this going to be up or down? Well, it starts down here on the ground, and it ends up 30 meters up in the air, somewhere up here. So from start, where it starts, to where it finishes, it goes up. So that vector is going to be up too. Both of these vectors point up, which means that when I plug them into the equation, both of them have to have the same sign. They can either both positive or both negative, whatever I decide. What else do I always know in a free fall problem? I always know g. And g is always downward. It's the acceleration due to gravity, and it is a constant 9.8 meters per second every second, or meters per second squared, and my unknown is t. So once again, I'm going to use this equation. Delta y is v naught t plus 1/2 gt squared. Let me rewrite it so that it's in the format that I'm used to solving quadratics in. And why don't you see if you can solve this now? Let's make sure you go back to this and make sure you're consistent about your signs. So 2 vectors are pointing up and 1 vector is pointing down, so figure out how you're going to deal with that. The answers you get, if you solve this correctly, should be, when you add them, 36.5 seconds, and when you subtract, it should be 168 seconds. So pause this, do the work yourself, see if you get it, and if you don't, come back and see how it's done. So you have 2 vectors pointing up and 1 vector pointing down. The way that I indicate that vectors are in different directions is by giving them opposite signs. I'm going to make downward negative. I could make downward positive if I want, but I'm going to make it negative. So in my problem, every vector that points upward is going to have a positive sign, this 1,000 and this 30,000, and everything that's negative, or that's downward rather, is going to have a negative sign, so it's going to be negative 9.8. I just have to be careful how I substitute into this equation here. 1/2 g is going to be 1/2 of negative 9.8, so it's going to be negative 4.9 t squared. V naught is 1,000, it's positive, minus delta y. Delta y is positive 30,000, so it's going to be minus 30,000. Equals 0. When I put this in the quadratic formula, I get t equals negative b, which is negative 1,000, plus or minus the square root of 1,000 squared minus 4 times minus 4.9 times minus 30,000. I have to put that all under a radical, all divided by 2a, or 2 times negative 4.9. And when you put that in your calculator, you should get these two numbers. So what does that mean? Because the last time it was easy. The last two times we got one positive root and one negative root, and we could get rid of the negative root because time's not negative. But here we have two positive roots. How can this be? How can it be that it takes both 36.5 seconds and 168 seconds for this rocket to go 30,000 meters? And the answer is that the rocket is at the position 30,000 meters. If we consider its starting point to be 0, and we consider its ending point, or the point I care about here, to be 30,000, it is at that position twice. It is at that position once on the way up, and that happens first. That happens here at 36.5 seconds, and it goes up and up and up, right? And then it's at rest up here at the very top at its maximum altitude. And then it comes back down and it's at 30,000 meters again, and that happens at 168 seconds. So in this problem, you get both positive numbers because there are two times when the object is at 30,000 feet. There are problems that you can practice to learn how to do this, and the next video will be how to apply this to solving two-dimensional motion problems.